Should you consume 21 spoons of ghee? Should you consume 100 pills to stop your aging? Or should you be scared of glucose? All of those things and more we will learn about once we understand how to interpret researchers. See, in today's world, there's a lot of people out there who are making information, and obviously I can't go and debunk those videos one by one. So what I'm going to do is I'm going to share the tools necessary for you to interpret what is correct and what is not correct. Okay, so this is going to be a series, and this video is going to be part 1 of that series. So let's start from the basics. Why do we need research? We need research to find evidence. Okay, research allows us to gather evidence. And why do we need evidence? Evidence allows us to prove or refute a claim or a hypothesis, right? So for example, someone says, hey, Shilajit increases testosterone levels. Now for me to actually know if Shilajit actually does increase testosterone levels, I would need certain evidence, right? So without any evidence, if I'm blindly just consuming something, it could potentially harm me, right? And so that's why we need evidence, because evidence helps us get closer to truth. Mind you that evidence is not truth, because unlike other things which I don't want to mention here, science does not work in absolute. Science works in probabilities. So you can say that evidence is actually probability of truth. Okay, not truth, probability. So when we say something has strong evidence, we mean there's a 90% chance that this is true, or let's say a 95% chance that this is true, or that there's a 50% chance something is true, right? So we basically talk in terms of probability, but it's never going to be 100%. Remember, science does not work in absolute, it works only in probabilities. Now, when we talk about evidence, there's different kinds of models, there's different grading system, and all of those things we learn. But from this discussion, you understand that evidence is not an absolute truth, which means that there's a certain percentage allocated to different kinds of evidence. Just to give you a basic example, let's assume there's a person A and there's a person B, and obviously they got into a fight. Police arrested both of them, presented them in the courtroom, and the judge asked them, hey, what happened? So A says, B hit me. Okay, and B says, A hit me first. Now, because the judge is listening to both A and B and they're presenting their side of the arguments, it's going to be very difficult for the judge to arrive at a conclusion. Because in this case, A could be right, B could be right, both A and B could be right, and both A and B could be wrong, right? So sometimes we need evidence, and evidence does not necessarily come out of the people who are presenting arguments, right? So they would probably need a C or a bunch of C and D and E and many more subjects who could be then witness to what exactly happened here. But then even in this case, the probability is not going to be 100%, because there's a good chance that A or B could have bought off C, D and E, right? But in this case, you have a better evidence, let's say a 99% or 95% probability if there was a camera on the street, right? But even then, it will not be 100%. Okay, camera is going to be a very high quality evidence, but it's not going to be 100% because somebody could have tampered with it with AI and whatever, right? So point I'm trying to make is that evidence is not same. Evidence is not absolute. Evidence can be graded, right? And the reason why we have to understand the grading of evidence is because today, when a lot of people claim, hey, I'm evidence-based, or this thing works because there's an evidence, you have to ask, what's the grade of evidence? How confident are you of this evidence? Is this evidence 95%? Is this 99%? Or it's a 50%, right? And so that's why we do researches. We gather evidence, and obviously researches can be used to obtain different degrees of evidence. And so we follow a system. And let me draw this pyramid. Let's assume that this is a pyramid of evidence, where we would say, let's say this is the highest evidence grade. Okay, let's assume that this is 90 to 95%, or maybe even 99%. Okay, then this might be, let's say, a comfortable 60 to 90%, and then you'll have like a 50 to 60%, and then something less and less, right? So we have this ranking system. If you look at some of the top bodies, they basically grade evidence on the basis of 1, and 1 is further divided into 1A, 1B, 2A, 2B, and you have C, D, E, and so and so. Right? So when we talk about this evidence-based pyramid, we have a grading system, and this was developed in 1990s. And so far, all the medical bodies, all the top authorities from WHO to AHA to cancer societies of the world, they all follow this grading system. So when we talk about different kinds of researchers which present different kinds of evidence, we can classify these researchers based on this evidence. So now look at the kinds of researchers first. I'll start from the bottom of the pyramid. So basic few terminologies. N basically is a sample size. So whenever somebody says n equals 1, basically they mean that sample number of people in the sample size is 1. Okay, just basic thing, because we're going to build on top of it, right? So whenever the n equals 1 and some sort of an intervention is done on one individual, and then you find out those results, those are typically referred to as case studies. Okay, case studies. For example, I took a medicine and then I felt amazing. I cannot generalize these results to everybody, because I'm just one person. I took something and then it worked for me. N equals to 1. This would be referred to as an individual case study. Now, case studies could be done in more than one people also, but the idea is that when you do interventions in a select group of people and follow them, those are typically referred to as case studies. They are usually the weakest form of evidence, besides anecdotes and different kinds of things, right? So anecdotes are basically not studies. Anecdotes is somebody says from their personal experience, oh, I went there, I saw a ghost, and yeah, so don't go there, that place is haunted. This would be referred to as an anecdote. So anecdote is not an evidence actually. Anecdotes are anecdotes. Okay, so anecdotes would be extremely low in the hierarchy, and then we have case studies, right? So, and then we move forward, we have expert opinions, which is like someone say, hey, you know what, I think this is how it should be, and I think this is how it should work. Again, expert opinions are valuable if they are based on something, but then expert opinions are not considered a very strong evidence either. I, as a health professional, I can suggest people, I can give my expert opinions based on data, but if they are not based on data, then my expert opinions are of no use, right? So I don't synthesize information on my own. Similarly, Google articles, expert opinion, case studies, all of these are some of the weakest forms of evidence, and obviously the worst is anecdotes and lies. So that these are not considered studies. Then we move on to second. The next one would be animal studies, which are referred to as in vivo, which is inside a living organism, usually done in rats, primates, which could be gorillas and stuff, and then could be in other animals also. They do it in sheep and other animals. Then in the same, you have in vitro. In vitro is basically in petri dish. Okay, so these are studies which are done in cell cultures, where they actually treat a single cell using some sort of a chemical or something, and then basis that they form opinions. Then you have in lab, chemical analysis, like the recent study which came out and said, hey, there's unexpected level of PFAS found in some high-end watches, bands, and then those are dangerous for you. They would come under this in-lab analysis, right? And they are usually considered not such a great evidence. Similarly, you have mechanistic studies. These are again good for establishing a mechanism of action, but they don't apply to humans directly. Okay, so all of these things. So you have the bottom of the pyramid. This would be expert opinions. And then you'll have anecdotes, articles, etc. And then you'll have case studies, in vitro, in vivo. You will also have mechanistic studies. Okay, then we move to different kinds of studies. Now these are basically case series. They would be slightly above in terms of evidence, so like a single case study, and so you'll have case series where multiple people are followed. And then you'll also have cross-sectional studies, which are like you have a larger population set, and then from that larger population set, you derive and follow a smaller subset. Basically, a great example is alcohol or how smoking causes cancer, right? So now, over a period of time, we have done a lot of case-controlled studies. We have done case series, cross-sectional observational data, and so they would still be relatively above in the evidence-based pyramid. They are good because we can't control these kind of studies on human subjects directly because of ethical concerns, right? So, and then you'll have cohort studies or observational studies, which is your epidemiological large-scale studies, which is the recent one which was published in Lancet, and it was about no amount of alcohol is safe for you, right? So these are observational studies. And then on top of that, you'll have RCTs or randomized controlled trials or double-blinded randomized controlled trials or controlled trials, right? These will be there. And then you'll have systematic reviews, meta-analysis. Systematic reviews, meta-analysis, and then you'll have Cochrane. Okay, so all of these are basically studies done on numerous RCTs, double-blinded RCTs, controlled trials, all of those things. These are studies, and when the studies are done in a homogeneous environment, and then you have systematic reviews and meta-analysis, then those would be considered as the highest evidence, right? So this is really the evidence-based pyramid, roughly this and this. So this would be considered a 1A, systematic reviews and meta-analysis, RCTs and double-blinded controlled trials, and controlled trials would be considered 1B. Cohort studies, both of these would be under category 2A and 2B. Rest of these are C, D, E, and so and so, right? So as somebody says, hey, look, this and this study came out, and this is what they found out, all you have to is find out which study are they talking about. If Prashant is saying, hey, you have to consume 21 spoons of ghee every single day because there was a study which was done in Winchester rats, and they found out that ghee improved, LDL profile in Winchester rats, his studies would be basically C-grade evidence. That evidence cannot be applied to humans because we actually have double-blinded randomized controlled trials in humans where when they increased 10% calories from ghee versus olive oil, they found out that ghee actually messed up LDL profiles in human beings, right? So in this case, the evidence is more in the favor of not consuming ghee and consuming olive oil versus consuming ghee, which Prashant is suggesting, right? So that's where the nuance comes in. If you understand this pyramid, you'd be able to gauge the tenacity of the argument that someone is making and how much weight the argument carries based on the kind of studies that they're quoting. I typically rely on systematic reviews and meta-analysis for everything that I say. Sometimes I do refer to observational studies if they have some backing of mechanistic studies. Look, you can do a clubbing of these things to arrive at much better, more nuanced, educated conclusions. But it's always a good idea to refer to systematic reviews and meta-analysis just to be on the safe side, especially if you're prescribing a protocol per se, okay? RCTs and double-blinded RCTs, they are good to have, good to go, like read them on a one-off basis. But honestly, even if you didn't pay any attention to those, you're not gonna miss out on anything. These things, case studies, in vitro, in vivo, cross-sectional, all of these studies can be safely discarded. They are of no use in practical considerations and practical terms, especially if you are working with clients. If you're not subject matter expert, these things don't apply to you, okay? So you can make post on Instagram, fear-mongering post of Instagram. Like recently somebody made a post on how there's the amount of PFAs in the smartwatch bands was exceeding 1,000 parts per billion, but it was a lab study. The study did not find out how much was the PFA being absorbed in the skin, or and what percentage of absorption was happening, and what were any kind of side effects on humans if that was consumed. I mean, if somebody has to use their brain, they would be able to find out that we are exposed to PFAS on a regular basis from everything. And to be very honest, if we are ingesting PFAS, that's far more dangerous than just having a band containing PFAS. And ingesting PFAS is actually pretty casual these days. The food, the water we drink, they all have PFAS, right? So the last thing I'm going to worry about is PFAS in my smartwatch. But yeah, you have people out there who are making these kind of crazy posts like your smartwatch can kill you and it can lower your immunity and whatnot. That's because they don't know how to make shit content. You don't know how to filter out shit content from legitimate content. Okay, so now that we have discussed the type of studies, let's also talk about where can you find these studies. So roughly there are about 30 million odd studies, I think, indexed on these two websites. So you have PubMed and then you have Google Scholar. Okay, so you go to these websites, you would be able to literally filter from 30 million odd studies, and not all of these studies are actually good. So according to estimates, roughly 5 to 10% of all of these 30 million studies are good. They are systematic reviews and meta-analysis. 70% of all these studies are not replicated. Like the results of these studies could not be replicated. And a lot of these studies are pure nonsense. For example, in 1994, a bunch of scientists did a study on basically a bunch of subjects, and they made them wear wet underwear in sub-zero temperatures to conclude that, yeah, wet underwear is going to make you feel cold in sub-zero temperature, right? So that's the kind of research we are talking about. And that's not the only one. I think there was a research in 2009 where they showed pictures of beautiful looking and not so beautiful looking human beings to these chickens, and then they concluded that chickens prefer company of beautiful people, right? So when somebody says, hey, according to research, you have to understand that the researchers could be good, could be bad, could be utter trash. Okay, for example, this PFS study and the same study with Winchester rats and he improving their LDL profile. Then the study about protein and cancer, that was a mechanistic study, by the way, right? So again, very low in the pyramid base. We don't have high quality systematic reviews or meta-analysis proving any such thing, right? So this brings me to the second part of the subject, which is journals, right? So you have all these 30 million studies and they are indexed on PubMed and Google Scholar. And when you click on them, you'll be able to see the abstract, and then from the link, you'd be able to visit journals. There's over 1 million journals, and these journals are good, bad, and ugly. Some of the top journals are Nature, you have Cell, obviously Lancet, then you have the BJEM, which is the British journal. Then what else do we have? Yeah, so these are some of the good journals which have there's something called as an impact factor. Roughly 60 to 100 is the impact factor, and some journals out of these have even more. And then there are some really bad journals, right? So if I have to talk about the credibility of journals, you basically use something, you can use impact factor, not always, but it's a good reliable measure. If the impact factor is greater than 10, greater than 3, it's palatable. Okay, like you can, look at the researcher and say, okay, seems like a good journal, okay journal, wouldn't say good. If the impact factor is greater than 10, then it's like a good reputable journal. If the impact factor is less than 3, shady. I wouldn't put too much interest in anything that's published in journals which have a impact factor of less than 3. And the reason for this is because a lot of these journals are actually paid for journals. You can literally pay them to publish any kind of study you want in these journals. They don't filter, they don't have a criteria, just pay them the money and they'll publish your research. Researchers themselves suffer from inherent problems. There are biases, messing with data. and when I'm saying messing with data, there are scientists who literally falsify the data. Then cherry picking. So when they publish studies, the references can be cherry picked. Then there's the funding biases. And a great example of funding bias is all the Shilajit and Ashwagandha studies. All of the studies which have proved anything, they basically are funded by the same companies that sell them. Same applies to collagen studies. So most of the companies, most of the studies that say collagen is good are actually funded by collagen companies, right? So you have funding biases, then you have conflict of interest. Historically, there were a lot of studies which were published by scientists who received a grant from some of these cola companies. I'm not gonna take explicit names. And for a very long period of time, they established that, hey, sugar is perfectly fine and it's not gonna be any problem and everything. So, those were studies which were funded. So big sugar, big alcohol, big meat, big vegan, all of these are industries and lobbies, and they provide grants via, and there are scientists, because at the end of the day, everyone could have family, right? They have mouths to feed. So they take money and they publish studies which further the narrative of these companies, right? So you have big pharma, you have big sugar, you have big alcohol, big tobacco. Then what else is there? Yeah, so there are lobbies and big vegan. You'd be surprised. There's now also big organic, right? So anything here which is more than $1 billion plus industry, they have their lobbies, and what they do is they channel a lot of their money into publishing studies which further their own agenda. Big meat is also there. So there are literally meat industry funded studies that tell you to eat more meat. Similarly, there are literally studies funded, in fact, documentaries. What the Food, I guess, that was a Netflix documentary which was funded by the big vegan industry. Then you have big organic, you have big alcohol, tobacco, pharma. There was a time when, cigarettes were promoted openly back in, I think, 50s or 60s. And they were supposed to help people, and it was literally promoted by doctors, right? So when we talk about all of this industries and researches and everything, there's a lot of ifs and buts, and science isn't sexy, it's messy, it's got its own share of problems, right? So you have to navigate very, very carefully when it comes to science. So just because somebody says, hey, this is evidence-based, you have to really deep dive into the evidence. Now, I've given you some background into where exactly to begin. In the next series, because I think this video might exceed more than what I intended to, what I'll cover is I'll probably get into study methodology, then we'll talk about data, we'll talk about different kinds of plots, different kind of statistics like SD, and then we'll talk about variance, p-values, effect size, correlation, all of these things. We'll talk about alpha, beta errors. All of these things we'll talk about probably in the next session, and it's going to be super boring. So I'm just giving you a warning right now. Okay, for this session, I think this is good enough. So next time somebody claims that there's a new study which came out, and this study says this thing, look at the evidence-based pyramid. You can easily find it on the internet, and ask them, hey, your study is a case study, it's an expert opinion, or it's a in vitro, in vivo study, and it's not a systematic review, right? Or it's not a meta-analysis, it's not a RCT, so it doesn't really matter. So stop fear-mongering. With this, I hope you learned something new. Thank you so much, and have a great day.